histogram tool is somewhat pertain to the normal distribution, but there are some interesting other things that we can get from here. So histogram is basically a frequency distribution tool which help us to identify that which particular class interval or which particular range has some kind of variance. Like in box plot, we only get 4 ranges: Q1, Q2, Q3, Q4. However, if we look at the data from a holistical view, we want to figure out that which particular range has maximum number of issues or problems. That is something which we can do it with the help of histogram. So histogram is a graphical representation of the data, which help us to identify the overall distribution of the data. And when we say distribution, which says the minimum value, the maximum value, and all the values. So what it does is it divides the data into different bins. Bins means class, interval, or range. So we are not giving any kind of range. The data itself calculates a range. And the height of the bin shows the number of frequency of data point in the group. Okay. So with the help of histogram, we are able to figure out three things. Okay. First is the overall distribution. That is something which you can check in normal distribution also. So that is nothing new. Okay. The important thing here we can see is the data being divided into different bins or class intervals, like from 0 to 10, from 10 to 20, from 20 to 30. And we are able to figure out that which particular bin or class interval needs to be focused. Okay. So the height of the bin, which I will just show you, shows the number of frequency. Okay. And the group shows the class interval. So let me just show you a practical demonstration of the histogram tool, and then you'll be able to see what best we can get from there. So histogram is also one of the 7 quality tools. So I will use the similar data that we have. We can use the same data and use histogram. So I have a histogram tab as well in this data. I'm sure you must have seen this data table that I've shared with you. So histogram. Okay. So guys, I have data for month-wise data, and I've got number of defects here. Okay. So I select this entire data and I switch to mini tab, clicked on another worksheet, pasted this data. And now I go to graph and I go to histogram. So let's click on the simple. I click on OK. And I click on number of defects. Okay. And I click on OK. Now here, if you look at it, this is a histogram. So here it shows the spread of the data on the y-axis, number of defects, which range from 2 till 26.5. Okay. Here is a spread of the data that we can see. Now, all these buildings that you can see, all these bars that you can see is the frequency distribution. It tells how many data points that we have in these frequency distribution. It also shows us the range or the bins. So let's see how. If I click on any of the towers, it says bar value 7, which means this has 7 data points and the bin is 22.5 to 23.5. So between 22.5 to 23.5, we have the highest number of defects, which is 7. So this class interval is being calculated by data itself. We did not give any kind of information. The data itself has automatically calculated that what should be the class interval. Let's say if I click on any other tower, let's say if I click on this tower, this says between 18.5 to 19.5, we have 3 values here. Okay. So therefore we would be able to conclude. So guys, from this example, we would conclude that these 2 towers have maximum number of defects, which is here it is 7 and here it is also 7. These 2 class intervals, 22.5 to 23.5 and 23.5 to 24.5. So basically I would conclude from 22.5 to 24.5, I have highest number of defects. So this particular bar value or this particular bin requires more focus as compared to other bars. This is what we can check with the help of histogram. Anytime if you have any data on which you want to figure out that which particular bin or frequency needs to be focused, you can use a histogram to conclude that.
But I have one question. In this case, conclusion is not clear. Means here 23 to 23.5, these are itself a defect. So what we are concluding from this? That this
If
22.5 to 23.5 it itself a defect. So what
when
we are concluding this from this?
okay, so it is we are concluding that between 22.5 to 23.5 number of defects, we have 7 number of defects here. So this is a range that has been calculated, and number 7 is the frequency number of defects. So these bar value or bin value has been calculated by data itself. We have not done it. Depending upon the data, this is calculating the bin value on its own and giving us a bar value. Bar value is the number of defects in this particular data set. Okay, so let's look at this data. Let me show you the data also, and then you will be able to understand. Guys, I hope the Excel sheet is visible to all of you. This is the data that I have. Okay, so you can see here data count that we have 22, 23, 24. So how many data points that we have here? We have total 30. We have total 36 data points we have. Okay, which means we have got 36 defects. Correct. Now these 36 defects are in some range, means between 15 to 20 5 defects, between 20 to 30 there are 3. This is something which we have not given. So what the beauty of histogram is, it calculates scientifically and statistically and calculates the range on its own, and with that we are able to figure out which bin needs to be focused. So in this case it's telling us that since it's a number of defects wala data, and the higher the number of defect is, it is not good for the business. So therefore we would conclude that these bars have high number of defects, 7 and 7. So 20 defects in this bar and 23.4 to 24.5 defects in this. Guys, anybody has any doubt or any question, we'll take another example as well, but any question on this I would be happy to take one.
Sir, I couldn't get what you meant by bin.
Okay, bin is a okay. Bin is a class interval. It's a range. Like when we go for any frequency distribution, uh, we get some kind of ranges which we need to calculate. But this time Minitab is calculating for us. So let me just do it for you. In this data, if I click any class interval, let's say between 0 to 20, 0 to 10, 10 to 20, and 20 to 30. Okay. Let's take 0 to, let me take 0 to 20 here because we don't have that much data point here. So 0 to 15, 15 to 20, and 20 to 30. Let's say we have data points till here, which we include. Just focus on the color ones. Okay. Now guys, tell me how many frequencies that we have between 0 to 15 here in from this data. Tell me the count. Where is 16 here? Between 0 to 15, there is none.
Zero, na?
It is
Zero.
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 Zero. How many do we have between 15 to 20 here?
4.
Okay, let me just see also. Between 15 to 20,
Yeah,
we
4.
have 1, we have 2, we have 3, we have 4. Very good. And between 20 to 30, how many we have? 1, 2, 3, 4, 5, 6, 7, 8,
12.
9, 10, 11, 12. Yeah. So this is a bin and this is the frequency. Instead of doing it manually, the tool is doing it for yourself. And here you don't have to give any kind of range. हमने यहाँ पे अपने तरफ से range दी थी ना 0 to 15, 15 to 20. Now look to get this example. Which particular bin has most number of errors?
20 to
20 to 30.
So where would you focus? 20 to
20 to 30.
right? Let's take one more example. Let's take one more example. So I go to graph and let's say I do it on the tenure data that we have. Now let's look at this data, guys. Okay, let's click on any of the bars first. So in this particular case, guys, what is the bin value that we have? Guys, what is the bin that we get here?
8.75 to
8.75 to 11.25.
And how many frequency distribution that we get?
4.
4. Okay. And let's look at here.
23.75 to 26.25.
Right. Did we give any kind of command to Minitab that which bin should we calculate? No.
No, sir.
The tool itself calculating depending upon the data and telling us that in this data, which we are analyzing, which particular tenure of the people needs to be focused. Okay. So now the highest bin, so in this case, we get 3 bins of a similar range. Okay. Usually, which doesn't happen too often, but let's conclude this one. It says people who have tenure between 13 months to 16 months, just to round off, has highest number of defects. You would focus on these people and you will ask question, ki rest of are good to go, but why do you get highest number of errors? I'm just giving an example depending upon the analysis you're doing. If you're doing a data on productivity, then you will not question the highest one. So depending upon the data, productivity higher the better, and errors the lesser the better. This is how what you need to use your logical skills to analyze the data depending upon the type of data that you have. But I'm sharing a concept with you guys with some few examples that histogram help us to do 3 things. First, the spread of the data. Second, the bins, and third is the class intervals. And it also help us to focus on which particular frequency distribution or bins to be focused on for improving our processes. Okay, why it is to be done? Because when we look at any data, it is very difficult to identify that which particular range has a problem. Okay, and we can't see it scientifically or statistically also. But this is giving me a statistically because it is calculated a bin on its own. I have not given any kind of command. In your organization, you might be using your own range like 0 to 2 years, 2 to 4 years. But here, if you change the data here, these bins will be changed on its own. And that's why you see the bins are in percentage, in decimals. So this is what we will do with the help of histogram.
Sir, can you go to the Excel? I have one question.
Which Excel? The histogram one or the one we just
Histogram one, sir. The recent we took exam. Yeah. So as you said that on 20 to 30 we have an more defects like a 12 defects we have. So now from this whole data from 2 to 17, so where we have to focus now means on April month, April 2003. After that, March 2003. There we have to focus to identify the cause, right?
No, this is just example given for the months data, but here we are not concluding on the months. The focus is not on months here. The focus is on the bins, and bin is the class interval that we get. So here we are focusing on between 20 to 30 defects. Okay, it has calculated a range on its own that 12 defects that we get between 20 to 30. Okay, so which means on 12 occasions we get defects between 20 to 30, which means here in this example, how many times? So let's focus on this example. Now, if I want to ask you between 20 to 30, how many defects that we get? This is what we concluded here. Okay. So which means it's telling me that we get 20 to 30 defects. We get 12 defects between 20 to 30. Okay. So it is not focusing on the month, Month is just to give a reference value that this data is for these many months or these many weekly data, but the focus is on the bins. All right. So any question anybody has? Okay. So guys, with the help of that, we have concluded some of the tools which are part of 7 quality tools. There are few which are left. So histogram is done. Now the next tool is called the flowchart. Guys, flowchart is basically like your process map, okay, wherein we map the process in and out, starting from uh, the first step of the process till the end step of the process. Okay, flowchart help us to identify the issues and the problems in any given data. Sometimes when we face any problem and when we don't have any kind of data, we probably have to revisit our processes. Okay, and with the help of our processes, we would be able to find out where the problem is. Let me know if there is any problem in the screen. Let me just put it up once again. Is it visible now?
Yes.
Okay. So now in this example, okay, we see that there is a process, okay, which is pertaining to lamp. Okay. So it says lamp doesn't work, lamp plugged in. Okay. If it's yes, bulb turn out. If it's no, repair lamp. If it's yes, replace lamp bulb. So any given process you would look at, you would have some kind of rectangular boxes, some kind of decision boxes, some kind of oval boxes. These are some of the standards that are being followed to ensure that everybody understand. However, the intent is that we are able to figure out the areas where the errors can come. Okay. So anytime when we face any problem, it is the process map or the flow chart that needs to be looked at to figure out if there's any particular problem in that flow chart or not. Okay. And therefore we would be able to focus on that particular area. It is as simple as that during any kind of problem, we look at our manuals, we look at our reference notes to see where we went wrong. Similarly, flowchart is like a process map, which is the pictorial representation of any process that we have, and with the help of that, we are able to see where the actual problem is, where did we go wrong, so that we can improve it. It also helps us in identifying the non-value added steps. Okay, uh, so that we would be able to identify the gaps in the process as well. Okay, so these are some of the shapes, guys. The oval shape that you can see here and here, this is for the start and the stop of the process, where we begin the process. This rectangular box is for the process, is for the data, is for the information process steps for any activity that we have. This decision boxes is for the scenarios. Okay, so like for example, if we take an example of IRCTC, we say if it's a senior citizen, we do this. If it's a woman, if the person is alcoholic, etc., etc. Okay, so this flow chart or process map is very useful in identifying the various gaps in the process. Flow chart or process map can be used outside the Six Sigma project also, even though if you're not doing a Six Sigma project. But it is always necessary to have the flow chart and the process maps being created for all the process steps, for all the processes that we have in the organization. This would help us to identify a lot many spots in the problems, in the focus, and then there how we would be able to fix the problem and increase the efficiency in the process. So this is one thing I would recommend to all of you in your respective organizations, wherever you're working. Please ensure that there are process maps being prepared so that you'll be able to figure out some kind of inefficiencies in the process itself. Okay, so you can, as I mentioned earlier, you can use various tools like Visio, you can use it on Excel, you can use it on PowerPoint. There are various ways to do it, but Visio is a paid tool. Not sure whether your organization will allow you to do it or not. Okay, but you can use Excel and PowerPoint to use these kind of shapes to prepare the flowchart.
In this flow chart, we need to define the responsibilities also.
No, not
Okay.
necessarily. That is not required here. If you use a swim lane chart, okay, that is a core process value stream mapping, which is something we discuss in the black belt training, uh, wherein we focus on the swim lane charts, wherein we give a responsibility. But I'm just talking about a normal process flow without giving any kind of, it's not responsibility, it is a department or the teams who are involved. Okay. That's how we are able to figure out that whether this is done by HR team, finance team. Okay. So I'm not talking about swim lanes. I'm just talking about uh, a simple process map, which is one of the 7 tools of quality which needs to be there. Although there are many types of process maps, okay, but this is one of the important and essential process map which needs to be there to identify issues and problems. Okay, so this is flowchart. The next quality tool that we have is called the check sheet. Okay, check sheet is a kind of tool or a document which help us to identify the issues at a real time. Okay, if we are maintaining a check sheet, if you're maintaining the data at a regular basis, we are able to find out lot many things, lot many issues in the data itself. Lot of people, lot of teams are preparing check sheets to identify the issue. So if a check sheet is being prepared already, we are able to spot errors and able to make some conclusions. Okay, so let's take one example here. This is one of the motor assembly check sheet. Okay, when we go and do our car servicing or car repairing, they are maintaining that kind of check sheet, and similar check sheet can be prepared for any process also. Wherein what we do is we put here on the y-axis the types of defects that the customer visits for. Okay, and here we mention the days of the week. You can mention it as anything you want. You can put it as monthly, you can put it as uh, weekly, daily also. Okay, now with the help of this, we are able to figure out that this particular problem is occurring on a daily basis, on a weekly basis, and what is the kind of frequency that we have. Okay, so let's take one example here. uh, Improper test procedure is one defect type which has not occurred in the entire week, which means this kind of errors, this kind of defects are not getting, which means the team is doing really good here. Okay, which means this could be a possibility ki last week this was there and that's the reason they have included. This week they have not got it. If I take example of this, supplied parts rusted, okay, which means the parts that are being used are not properly working. This kind of complaint is coming on 4 days: Monday, Tuesday, Wednesday, and Thursday. The maximum number of complaints are received on Monday. Now the team can question and get into it that what went wrong on Monday that we are getting maximum complaints. Okay. Masking insufficient. This kind of problem is coming only on Thursdays. Spray failure. This time of problem is coming on Tuesdays. So with the help of these insights, when you have check sheet in place, you are able to make some more conclusions, some more valuable suggestions for the process or business. Okay. So this is what a check sheet tool does. Help us to figure out where the actual problem is, where we are doing really good, which part of the day, which part of the week. You can prepare a check sheet hourly wise also. If your process demands, you can prepare it every 2 hours wise also. Okay, if you're monitoring a frequent, if you're monitoring a breakages, okay, and if you are maintaining the data on a 2 hours basis, you'll be able to figure out what kind of breakages are we getting, and then that's how you'll be able to conclude it. This is another type of quality tool, one of the 7 tools of quality, which help us to identify some issues and gaps from the existing data that we have. Guys, anybody has any question on the check sheet? Are we good? So guys, what we have done is we have completed the analyze phase as well. There are some more tools left which we will cover in the lean part as well. So there is a lean training as well that we will do, wherein we cover those tools as well. However, from the 7 quality tools perspective, we have covered, I'll just take you back. So guys, we covered Pareto, histogram, scatter plot, cause and effect diagram, which is fishbone diagram, flowchart, check sheet. and control chart is something which will be covered in the control phase of Six Sigma. So we'll take a break, dinner break now, since we will get into the improve phase and I want to start it fresh. But if anybody has any questions, we can spend time. Usually we take a break at 9:30, but I'm just kind of preponing it today because we have completed the analyze phase. But if you want to cover any of the tools in the next 10 minutes before going on a break, I'll be more than happy to answer your questions if you have any on the 7 quality tools or whatever we've covered today.
I have one doubt on box plot.
Mm-hmm.
So I'm basically new to box plot, so I'm not sure if it's correct. But what is the horizontal deviation that was seen in box plot? Like, does it represent something, or is it just the vertical thing we have to check?
Let me just take you through to that example. Give me a minute. So let's click on the box plot. Is my screen visible? Box plot can be seen to all of you.
Yeah. Yeah.
Mhm. So now tell me what your question.
So this box actually, does it represent something, the horizontal deviation, or
Yes.
is it just the vertical ch- check we have to see?
So box plot is a graphical tool which help us to figure out uh, the quartiles that have been divided into this data has any extreme values or any kind of deviation in it. Okay. So box plot basically divides the data into 4 quartiles. Box plot is to be done when your measure of central tendency is median, which means that there are uh, no kind of extreme values here in this data. Or sorry, there are some kind of extreme values in the data. That's why you consider median. Okay. Now, in that extreme values, you need to figure out that which particular range has that extreme value, right? Now, in order to get into which extreme value that we need to focus on, is that what we're using the box plot for? So it basically divides the data into 4 quartiles, Q1, Q2, Q3, and Q4, and basically tells us that this is the value or this is the range or quartile which has unacceptable deviation. Due to that, this data is not normal. If there was no deviation, then this data would have been normal. We won't be doing box plot. So because of the not normal data and we wanted to get to next level, we are doing a box plot.
So Simar, basically horizontal line has got no meaning because it's only the vertical line which symbolizes the quarter.
Talking about this line, you're talking
No,
about
Akshay is asking for the horizontal line. Does it has any meaning? So
which
horizontal has got no meaning. It's only the vertical.
Altogether, the horizontal axis is what the point, Simmer. Like
Yeah.
vertical axis, we have the values, and horizontal, we don't have any
yes,
values.
yes, right, absolutely, yes. This doesn't have any significance because there is only one value here. We are doing it only for the whole time data here. Okay, this represents the frequency distribution. Any other question?
Okay.